Hello again, my friends. So we're in review. We got some exams. Not a lot of them. So the Newman and I made some exams up. Now these can be found at nkinfinity.com. You just come over here to the website. See my ugly mug, my partner in crimes. There we are, NK Infinity. If you haven't done this already, here they are. You just go down to, where in the world are they? You just go down here to Regents Review. And in here you'll find there's test 1 and there's the answer keys. In just a few minutes after I finish this video, all 3 of these links will be live. Maybe when you're looking at it, they're already live. And then you get to watch. Now, again, I can say this every time I do this. Please, please, please make sure you are doing these problems on your own before coming to watch the Perform Monkey show you how to do these. I'm well trained. I know how to do these things. You have to learn how to do these things. All right, kids. Now, I'm going to teach you some things about the test, and I'm going to teach you some things about some mathematics. Now, this is part 2. Part 2s are not designed to be too difficult. You should be able to handle part 2s pretty easily. All right, so let's take a look. Look at this problem. Here's how we do these problems. Back to work. Lowest common denominator in this case is 6x. So I'm going to convert them all to 6x. The good news is right side's already 6x. Left side, I'm going to convert everything to 6x. And I'm going to watch me do this. I'll put this -1 up here and make this a plus. Why am I doing that? Because negatives are a pain in the neck. So I try to be careful with them. And then, so let's see. I had to multiply this one by 6. So this becomes 6. I had to multiply this one times x, so this becomes 1x. So really what I have here is 6 minus x over 6x equals -5 over 6x. Now again, remember, it's not designed to be brain surgery here, kids. We don't even need the denominator. As long as the numerators are equal to each other, we're done. 6 minus x equals -5. Let's see. How about we subtract 6, and I get, this is where you got to be careful, -x equals -11, so x is equal to 11. Certainly we should check this sucker. So we go over to our calculator, we take 11, got all this crap here, I thought I cleaned all this out. All right, so we're going to take 11, and we're going to store it into x. And then we're going to type in the right side. And the right side says 1 divided by x, 1 divided by x, minus 1 divided by 6. Ka-chang! What the? That's crazy. And then we're going to take -5, and we're going to divide it by control division. Let me do this one. I gotta be careful with this one. 6x. And I hit enter. Oh, look at that. The same crazy stuff. There's my answer. X equals 11. Done. Next problem. Maybe. Let me stop. I'll be right back. I gotta pause every couple minutes. All right. Let's talk about Howard and his fish. But before we do that, we gotta get some coffee. The coffee's a little cold right now. But still delicious. All right, so Howard collected eggs from the pond behind his house so he could do an experiment whether sunlight had an effect on how many eggs were hatched. Describe how he used a control experiment, how he can use in a controlled experiment to examine the effects of sunlight on the 2 fish. Well, first of all, you have to understand, on a controlled experiment, you have to have a control group. But before you have a control group, the most important word in statistics is the word random. So in this problem, if you decide not to use the word random, there's no chance of you getting full credit on it. Now, it's only a 2-point question, so it shouldn't take you that long. So I'm just going to describe it. I'll talk you through it. Be done. This is what you should have written. Something to this effect. What do we got? The first thing Howard should do is to randomly select 2 separate groups of equal size. Then one of the groups he should call the control group. What are these, in fish tanks? So in the control group, they should not get sunlight, or it should just be random light, I guess. Examine the effect of sunlight on the fish. So I guess one of the groups should get sunlight, and one of the fish should not, or what are these, eggs? The eggs should not get sunlight. And then he should observe what takes place and collect all the appropriate data. So the biggest thing about how to control this experiment is he has to randomly select two separate groups, call one of them the control group, and one of them the experiment group. The experiment group should get the treatment, whatever the treatment is, and in this case the treatment is sunlight, and the control group should not get the treatment, in this case the sunlight. So I guess they need to be kept in darkness. I'm not sure what that should be. Maybe what he should do is do it in 3 different groups. Maybe the best thing to do is randomly select 3 different groups. One control group where you just get regular light, one control group where you get no light, and one control group where you get sunlight. I don't know. But the biggest 2 things, all you really need to have in there is randomness, randomly selected groups, one control group, one experiment group. The experiment group gets the treatment. The non-experiment does not get the treatment. Done. Problem's over with. Let's go. Determine if it's a factor. Explain your answer. Okay, there are 2 ways to do this problem. I will show you both ways. The first way is to prove by showing by long division. So I will just prove this by long division. If this divides in evenly, oops. By the way, you need to explain your answer. So just if I do this math, it will not be good enough. So 4x minus 28. You have to explain your answer. So I'm going to do the math, and then I'm going to explain what happened or didn't happen. So 9x squared. So 9x cubed, and then 9x times both of these, right? So plus 63x squared. And then we're going to subtract. These go away, copy everything else down, minus 4x, minus 28. How many times does x go into minus 4x? Minus 4. Multiply by both. I get negative 4x squared minus 28x. Grab another pen. Subtract, which turns this into a plus, and this turns into a plus, and we get 0. And so you have to explain yourself. Since we get, since x plus 1 divides evenly, no remainder, into 9x cubed plus 63x squared minus 4x minus 28. Since x plus 4 divides evenly into, it is a factor. Boom. That's method 1 to solve this. The other thing is, the other way to solve this is to say this. If x plus 7 is a factor, this is method 2. That would have been perfectly kind, full credit. If x plus 7 is a factor of the function, it's not a function, of the expression 9x cubed plus 63x squared minus 4x minus 28, then x equals negative 7 must be a root of the expression. Let me just bring this up. In other words, if I substitute in negative 7 in for x, if I substitute, I should write this a little better. Substitute negative 7 in for x and get 0, then negative 7 is a root and x plus 7 is a factor. And then you should show your math. 9 times negative 7 cubed plus 63 times negative 7 squared minus 4 times negative 7 minus 28. And you show that equals 0. Boom, there you go. Done. Something to that effect, and you would have gotten full credit. All right, let's move on to a little bit of trigonometry. All right, let's see what we got here. On one period of amplitude 4, period of pi, midline of y equals 2, and passes to the point 0, 2. Okay, let's check this out. So I probably got to label these things. Let's see, what's my amplitude? So my amplitude is 4. And my midline equals 2. That means my max is going to equal 6, because it's always midline plus and minus the amplitude. So my max will be 6 and my min will be negative 2. So I guess I got to make every one of these 2. Every one of these 1. So 2, 4, and 6. And then let's go negative 2. And negative 4. And negative 6. Something to that effect. All right, so my period, which is B, my period, gosh, bless it. Period is the time it takes. Well, you should know the formula for period. Period equals, sorry, I got something on my finger. Period is equal to 2 pi over B. Now, what's my equation? And y equals A sine bx plus c. So if my period is pi, pi is equal to 2 pi over b. Cross multiply, I get b times pi is equal to 2 pi, or divide by pi and I get b equals 2. So I know b equals 2. So here's what I got. I already got my equation. Y equals, I know my amplitude is 4. It tells us that. 4 sine 2x, and my midline is also 2. Okay, so there it is. Now it says it goes to the point 0, 2. Well, there's the point 0, 2. Now I got to come up with a scale for the x-axis here. So let's see what I'm going to do. If I got to get the pi, this is my period. I always do x scale is equal to period divided by 4. In this case, pi over 4, because that gives me my 4 zeros. So I'm going to just make every 3 of these. It doesn't matter. Pi over 4. Wait, let's see if I can get there. 1, 2, 3, 4. Because it just said 1 period. It says graph 1 period, right? So there it is right there, 1 period. So pi over 4, pi over 2, sorry, pi over 2, 3 pi over 4, and pi. Okay, so again, this is my midline right here. Let me grab the bigger black one. So these are going to be my zeros. Every other one is a 0. And in between is a max and a min. Now, what does it say? It goes to the point 0, 2. Well, it didn't say. So in between these, we're going to go to a max, and we're going to go to a min. So maybe a better question would have been to be. There it is. Maybe the better thing would have been it goes to the point pi comma over 4 comma 6 or something like that to know that I was going to go up. Because how do I know I go up or down? Well, there's my equation. And there's my graph. Hopefully you did okay with that. I'm going to be doing a whole day of review on this, and you'll see it, underneath Algebra 2 Trig Review. So if you go over here to Mr. Krause Math, or excuse me, NK Infinity, and you do click on this Regents Review, at some point I'm going to be changing the look of this. There'll be some buttons up here. One will say practice exams. One will say spiral reviews, and it'll take you down to here. And then further down or somewhere in there, I'm going to have actual directed review, in this case on trigonometry, but not right now. All right, here we go. Hilton High School has a population of 1,435 students. The number of students that participate in a fall sport is participation band, including jazz band, is 130. If the probability that a student is selected fall sport. Now, here's the kicker right here. This or statement right here is your kicker. Right? There's your thing. And it wants to know the probability to participate in both a fall sport and band. So that band thing, that or band right there, that's going to be our kicker. But let's get our information down. We got total students. Equals 1,435. We got sports. We got 432. We got band, including jazz, but we'll just do band, equal to 130. And then we've got sports or band. Well, and that should be obvious that it's 454, right? So what is the probability of sports? The probability of sports is 432 out of 1,435. What's the probability of band? I don't know why I'm crushing this in here like this. 130 over 1,435. And the probability of sports or band, I should be using the symbols, or band, is equal to 454 over 1,435. Now, I did say this was the kicker, right? This or statement. When you see an or statement, you should write down the or function for probability. The probability of sports or, why did I write and here? It should be the or. Sports or band is equal to the probability of sports plus the probability of bands minus the probability of sport and band. So we're going to write that in. So 454 over 1,435 is equal to 432. Is that how many are in sports? 432 over 1,435 plus 130 over 1,435 minus 450. Oh, nope. Minus the probability of sports and band. So that's the thing we're actually looking for. So if I combine these two, I wrote so big I ran out of room. If I combine these two, what do I get? 562. I get 562. Although I'll write 6 just to be fun, 2 over 1,435 minus the probability of sports and band. So then I simply subtract off this 562 over 1,435. By the way, if you did not write this using probabilities, but you arrived at it a different way, that's okay, but you should be using probabilities. What you end up with is negative. Let me make sure my math is right. 454 minus 562, negative 108. So what you end up is negative 108 over 1,435 is equal to the probability of sport and band. Well, the negative, right? Because see this negative kind of comes with it, right? So I don't need the negative. I just turn them both into positives, and there's my answer. How'd you do? Problems bodied. Oh, yeah. All right, kids, this was a very interesting question. We saw this one. I don't remember where we saw this. I think we saw this on an old, I think this was on the original, problem similar to this was on the original Common Core test. The reason I say it's interesting is because it's actually an incredibly easy question, but not if you don't see something right away. So I'm going to show you two ways to do this. I'm going to show you the easy way, but not so obvious. Then I'm going to show you the harder way, which I call the harder way, a little more obvious. So the easy way is to simply start with this, 8y minus 5. My goal is to get y by itself. So what I can do is I can divide both sides by 8. So I end up with y minus 5 is equal to, I'm just going to do 1/8 x minus 2 squared. Well, I just got to get y by itself. So y is equal to 1/8 x minus 2 squared plus 5. So my vertex, because this is vertex form of a parabola, my vertex is 2, 5. Remember, it comes out opposite and stays normal. Opposite, normal. So there's my vertex. Now, if I draw a simple, quick sketch of what's going on, my vertex is at 2, 5. My focus is at, or my directrix is here at y equals 11, or y equals 3. So if this is 2 down, then I go 2 up to find my focus. So my focus is at 2, 7. And that problem's over with. And that's the answer. Now, how can I do it a slightly harder way, but use this technology? How can I use technology to solve this? Well, I can start by distributing the 8. Let me just do that right away. 8y minus 40 equals, and if I double distribute this out, I get x squared minus 4x plus 4. Bring the 40 over, so I get 8y equals x squared minus 4x plus 44. And then divide everything by 8. So I end up with a parabola that's 1/8 x squared minus 1/2 x plus 11 over 2. Something like that. That's the simplest form. You could have just left it like that. And then what am I going to do? Well, I'm going to graph this thing. So I'm going to go to my calculator. I'm going to graph it. Menu. Oops, just graph. So 1 divided by 8x squared minus 0.5x minus 5.5. Now I just put it in as decimals. You can put them in as fractions if you want. It's just easier with decimals. Enter. Oops, I didn't type that in right. It's plus 5.5. So hit tab, hit the up arrow, boom, boom, boom. Sorry about that. This should be plus. All right, so there's my equation. So what you could do now is, and you'd have to describe this using your graphing calculator. There's a couple of different ways. You could right now say, okay, menu, analyze graph, minimum, click, click. So then you could say something to the effect of, I graphed the function on my calculator and got 2, 5 as my vertex if the directrix is y equals 3, the focus is 2, 7. Up 2, down 2. Or there's actually a feature on your calculator where you can go menu, analyze graph, conics, and if you click on that, one of them is foci, finding the foci. And all you got to do is click on the graph, and there it is. Click on it, it tells you it's 2, 7. You just click on it. It tells you it's 2, 7. I got to click on it. But and that thing's kind of in my way. Oh, there it is, 2, 7. Plots it for you, 2, 7. Done. And then, so how would I explain that? I would say menu, analyze graph, analyze conics, write this out, and then foci. And then click on graph. And then say it's 2.7. Either way is fine. I like my first method the best. I think it's fastest. Shows more math, but whatever. Either way is fine. Okay, that's that. All right, so anytime you see this word right here, prove. What you got to remember is this. You're only allowed to mess with one side. So I'm going to mess with, I think I'm going to mess with the right side. It doesn't really matter, but I'm going to see if I can make that right side look like the left side. So as I look at that, I want to find my lowest common denominator. Again, it's a 2-point question, so it shouldn't be too hard. This is the hardest part. My lowest common denominator is actually n times n plus 1. That's my lowest common denominator. So this first one, if I make each of these n plus 1, n plus 1, this one has to get multiplied by n plus 1. So my numerator is n plus 1. This one just had to get multiplied by n, so this is n. This is n. Well, I'm going to keep this over here, 1 over n times 1 over n plus 1. So if I combine now these both over n plus 1, this numerator, this n, cancels with this n, and I end up with 1. So I can rewrite this as 1 over n times 1 over n plus 1. This is an equivalent statement. So 1 over n is times 1 over n plus 1. And you proved it. That's all there is to it. But you got to remember, you're only allowed to mess with one side, not both. All right, let's pert it up, kids. So Victoria purchased a house in 2010 for $90,000. In 2016, she sold it for this much. Assuming exponential growth, approximate the annual growth to the nearest 100%. So I'm going to use the function a equals p e to the RT. Exponential growth. All right, let's do this. My final amount is $112,000. My initial amount was $90,000. E, now what's my growth? Oh, we don't know. R times 6, because it was for 6 years, correct? All right, divide by 90,000. By the way, have you learned how to cast out zeros? I hope so. These zeros go, these zeros go, these zeros go. And then I get 112 over 90 is equal to e to the 6r. Now to solve this, you need to take the natural log. Now you remember, anytime you have an exponent that you're looking for, anytime you have an exponent, you have to, you know this is either going to be log or natural log. In this case, because it's an e function, you use natural log. So the natural log, base e. Now remember, when you do natural logs, that can't go in, but it's all about the base, about the base, about the base. I should link to my music, my great video of this. Natural log of e. Miss Newman and I were just banging it out. Ooh, that didn't sound very good. I'm going to have to put a link there so you know what I'm talking about, because that's a little, yeah, whatever, let's keep going. Anyway, anytime you use natural logs, you're not going to put in the e. So, so I'm going to put it there just so I know where it goes. So natural log base e of 112 over 90 is equal to 6r. Divide by 6. Divide by 6, and I get, I don't know what I get. Oops, wrong one. So I forget the natural log, control natural log. Notice there's no place for a base. Notice whenever I use the word log, there's a place for a base down here, right? See this place for a base? But when you use natural logs, it's understood to be e, so you don't have to bother putting it there. 112 divided by 90, enter, divided by 6. So 0.036. Now don't round yet. 0.036, I got it written down here, 4482 4482000161. I write everything down. Now, what do I want? To the nearest tenth of a percent. Now, this is a 2-point question. You just go through all this amazing work, and you're going to go, oh, it's 0. What? Look, you got to move it. You got to multiply by 100 once, twice. So this R is really equal to 3.6448, or my rate is equal to 3.6%. And there's your answer, 3. Oh, wait, nearest hundredth of a percent. I misread it. I just lost a point because I misread it. 3.64%. Bam, there it is. Now, what a normal kid would do, what a bad kid would do, they just round that and say 0.04. No. That's a decimal. You need to turn it into a percent by multiplying by 100. I hope that's not behind my big head. I'll check that out too. Be careful with that. Alrighty, here we go. We're at part 4, or part 3. Part 3. So these are 4-point questions. You need to show more work, and you get lots more partial credits, but you really, truly need to show more work. So how are we going to do this problem? This is an interesting question. Let me see how we're going to do this problem. I think maybe the best way to do this problem is just solve a system of equations. You see how this is x squared here? And xy, x. If I multiply this equation by 8, I can get rid of xy's. So I get 4x squared plus 8xy equals 40. And then I get 24x squared minus 8xy equals, am I recording? I am. Equals 16. Now I'm just going to add these up. So what does this give me? 28x squared, these just go away, equals 56. X squared equals 2. Take the square root. Now here comes the tricky part. If this is going to work, I hope this works. I'm pretty sure it's going to work. Take plus or minus. And so I get x equals plus or minus the square root of 2. Well, now what? Well, I'll plug it back into one of these equations. This one's got all positive, so maybe I'll plug it into this one. So I get 4 times the square root of 2 squared plus 8 times the square root of 2 times y equals 40. This is going to be an interesting problem. So this piece is just 2. So this becomes 8 plus 8 square roots of 2y equals 40. Well, if I subtract 8, I get 8 square roots of 2y equals 32. Divide by 8, I get the square root of 2 times y is equal to 4. And now if I divide by the square root of 2, I get y equals 4 over the square root of 2. But you can't leave it like that, so you got to multiply by square root of 2 over square root of 2. So I get y equals 4 square roots of 2 over 2, which is really just 2 square roots of 2. So my first point of intersection appears to be the square root of 2 comma 2 square roots of 2. But remember, that was just plugging in that positive square root. I also got to plug in negative square root of 2. So I'm going to do back into this equation. So 4 times negative square root of 2 squared plus 8 times negative square root of 2 y equals 40. This is still positive 2 because negative squared is positive and square root of 2 squared is just 2. So this is just still 8 minus, though, see how this is going to be negative? 8 square roots of 2y equals 32. Negative 8 square roots of 2y equals, equals 40. Sorry, I was jumping the gun here a little bit. Now I'm going to subtract the 8. And I get 32. Divide by 4. or excuse me, divide by -8, and I get the square root of 2y equals -4. Divide by the square root of 2, divide by the square root of 2. And you're going to end up with the same math you did before. So I end up with y equals, in this case, -2 square roots of 2. So my second answer is going to be negative square root of 2, comma, -2 square roots of 2. So final answer, making it look all pretty. The square root of 2, comma, 2 square roots of 2. And negative square root of 2, comma, -2 square roots of 2. Great question. Is that right? Appears to be right. All right, so when I saw this one the first time I saw it, I'm like, what is this? And it's not my favorite question just because I'm really not a fan of this thing, but they wanted you to use this geometric S sub n formula here. And if you go over to your thing, you find it right here, geometric S sub n formula. So let me write that down, and then I'm going to show you where a small confusing part for most kids is going to be. So it's S sub n is equal to, keep going back, you go back and look at it, it's just a fraction, a1 minus a1 r to the n minus r to the n. So formula is a sub 1 minus a sub 1. Damn, that looks like 9. I hate a's. I always make them look like 9s. R to the n all over 1 minus r. Now, there's a small tricky part with this one. And that's this rate thing. Do you see how it's a 3.2.5% increase? An increase in rate is going to be 1 plus the percent increase. So in this case, my rate is going to be equal to 1 plus 0.0325. So as I use this formula, I got to use it properly. I'm investing $22,400 minus $22,400. See, to me, the reason I don't like this is it's like magic. Why did it happen? Why does that work that way? Whatever. It's not my favorite formula. 1.0325 because it's an increase. If it was a decrease, I'd use minus that. To the n all over 1 minus 1.0325. So that's part A, plugging in numbers into a formula. That's why I'm not a big fan of it. I don't care about this formula. I don't know why plugging numbers in is a big fan, but at least you get you to part 2, which is where you really earn a little bit of money. So maybe, I don't even remember, you probably got only 1 point for plugging numbers in. Maybe you got 2 because you had to remember this. Whatever. Use this formula to find Bob's total earnings in 12 years. Oh, wait a second. I forgot. This one, all we had to do was plug in 12. It's just not my favorite. So S sub 12 is equal to 22,400 minus 22,400, 1.0325. We're modeling this problem. I know this is our problem, but we're modeling it after one we saw on an old Regents exam, which, whatever, 0325. As you can tell, I'm not a fan of this question. When I first saw it, I was like, what is that? Why? So I go over to my calculator, because I have to. I hate using, by the way, I don't know if you noticed, I hate using the calculator. 22,400 minus 22,400, parenthesis 1.038, parenthesis raised to the 12, all over 1 minus 1.0328. Is that right? Oh, 325. Why am I using 38? Wait, it's 0325. Maybe I should use the right number. 0325. So 1.0325. 1.0335. There it is. 322,454. So I get 322,454 point. So 39, right? 39. The 4 I'm not going to round, so it's just 0.39. That's it, kids. That's all she wrote for that sucker. So for any of you that went through my or our NK Infinity program for Unit 10, which may or may not have been too many of you, or the only who studied my videos on this, you'll know that I covered or if maybe you know this or don't know this, is that I covered the statistics stuff a little bit more in depth of what you're going to see on this test. And that's because I think it should have been done correctly and accurately. So these problems that they put in these Algebra 2 tests aren't my favorite, but we tried to come up with some models that were relatively similar. So this is one I'm sure you're coming to visit because you probably don't understand it exactly. So I want to make sure you do understand what's going on in this problem. So Fitness Blender, look it up online. Miss Newman loves Fitness Blender. It's some fitness program. Every once in a while, I can catch her across the hall doing fitness in her classroom. Calling you out, Nooms. Anyway, Fitness Blender is an online exercise channel. Is considering whether to create a new 8-week workout challenge. The owners will launch a new program if at least 35% of its users will purchase the program. 50 users are randomly selected to take the survey. 13 out of 50 participants said they would purchase the new program. The owners of the Fitness Blender then devised a simulation based on the requirements that 35% of their users will purchase the program. Each dot on the graph represents a proportion of users who would purchase the new program. Each sample size, so each one of these dots represents 50 sample size, and there's 100 dots here. So you'll see that it is centered somewhere around 35. Centered around here. All right. Assume the data is normally distributed and the owners of Fitness Blender want to be 95% confident of its results. Does the sample proportion obtained from only 13 out of 50 fall within the margin of error? So, yeah, so here's some things I'm not really a big fan of. First of all, they oversimplify things, and that is 95%. They want you to use 2 standard deviations. Well, it's not quite 2 standard deviations. If you were in my class, you know it's really 1.96 standard deviations. But for the state, we'll use 2. So we'll use our margin of error. The margin of error is quite simple. It's going to be equal to plus or minus our z star score, which in this case we're just going to use 2 times the standard deviation. Well, they really oversimplified things on this one as well. They gave us the standard deviation, which I've circled up here, which I don't think I circled before, but I circled the standard deviation already before. So it's equal to plus or minus 2 times 0.067, which turns out to be 0.134. So that is our margin of error. Oh, excuse me, plus or minus part. Standard plus or minus 0.134. So what we can say is this: we are 95% confident that the true population parameter, that's a parameter because a proportion. It's a proportion. It's a proportion because it's a yes-no question. Lies within the interval. And I'm going to do it this way. 0.35 plus or minus 0.134, or from, let me do this on my calculator. 0.35 plus 0.134, 0.35 minus, not 2 minuses, 0.134. So from 0.216 to 0.484, or from 0.216 to 0.484. Since our sample 13 out of 50 or 0.26 falls Well, I shouldn't. So I should probably just say our sample, 13 out of 50 or 0.26, does fall within this interval. Good enough. Fitness Planner decided to move forward with the new program for its users, even though only 13 out of 50 participants said they would purchase it. But remember, that's only one sample, right? They ran this simulation a number of times. Describe how the simulation data could be used to support this decisions. Based on their simulation, they can say that the percent of people will not fall below 0.216. Actually, let's say this. They can say based on the simulation that the percent of people will more than likely not fall below 0.26, which is what they obtained in their sample. In other words, the sample that they got was on the low end of this interval, 0.216 to 0.484. So 0.226 was on the low end. I could even say that, since 0.26 was on the low end of the margin of error interval. So in other words, they ran this simulation and they found out that the margin of error is going to be between 0.216 and 0.484. And 0.26 is on the low end of that. So it's very small likelihood that there will be anything lower than 0.26. So they can go ahead with it, and it should be, above 0.26, which is close to what they wanted originally. All right. Not my favorite question, I'll be honest with you on that one. I think I wrote much better questions in my class, but I think they're probably too difficult for this. I don't know. We'll see. My whole problem with that last question is I just don't think it was written. I think it was written sort of, and it was modeled after an old Regents, but I just don't think it was written that well. All right. This one's an easy one. This one's a straightforward average rate of change. Now, if you don't know average rate of change is just going to be slope, we got issues. And this is the interval between -1 and 1. So what we need to do is find f of 1. Why did I put an extra parenthesis there? Which is equal to 4/3 to the 1, which is really just 4/3. And f of -1. This is kind of the tricky part, I guess, but if you put it in your calculator, it's just going to tell you. If you put that in your calculator, it's just going to tell you that's equal to 3/4. So if I want the average rate of change, for this, it's going to be f of 1 minus f of -1 all over 1 minus -1. So this is equal to 4/3 minus 3/4 over, this just turns out to be 2, right? So maybe I'll use my calculator for that. Maybe I won't. All right, let's go here. Let's get rid of that. Let's go right to there. So control division, 3 divided by 4 minus 4 divided by 3 all over 2. Excuse me, escape. Enter, menu, number, approximate the fraction, enter. Why is it doing that? That's awful. let me change this back. Sometimes, I tell you, I love this calculator in most cases, but sometimes when you change it to approximate, let's go back to auto, make default. Okay. So let's go ding, 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 ding. I think it'll turn out to be nice now. It's negative 7 over 24. There it is. Why do I have negative? 4/3 minus 3/4. Oh. Yeah, I put it in my calculator wrong. I put it in here wrong. It should be 4/3 minus 3/4. Hey, see how that makes a huge difference? I totally put that in there wrong. The first one is 4/3. If you put it in there wrong, we got issues. Now, you really won't get the wrong answer because it doesn't matter whether it's positive or negative. But in this case, it's 7/24. But you would lose a point. I'd only get 3 out of 4 points because it had the wrong rate of change there. So the other rate of change is we're going to use this point and this point. So we're going to do the g. So this is going to be g of 1 minus g of negative 1 all over 1 minus negative 1. Well, g of 1 is 15 minus 7 over, and again, 2. So this is 4. So their average rate of change is 4. And you have to write of, which one says the question? Smaller rate of change. F of x has the smaller rate of change. And again, it doesn't matter if it's negative or positive. It's really the rate of change is its magnitude, which means the absolute value of that number. So even if this had turned out to be, well, even if this had turned out to be negative, which makes this a much smaller number than this, the rate of change is the absolute value of that. So remember that. It makes no difference positive or negative for rate of change. It's really a magnitude. All right. So this is an interesting question. This one, I'm not really sure where we got this one from. Basically what we did was we simulated some data here. Yeah, this is an interesting question. So on the graph below, number of daylight hours, a function of the day. The graph below shows the number of daylight hours for Fairbanks, Alaska as a function of the day, the number of January 1st, January 2nd, and so on and so forth. I guess this is throughout the year. Now, if you think about it, you know, temperatures kind of go like this. They go up, and then they go down. They get really cold. They come back and go. So this would be more of like a trigonometric curve, so to speak. So let's see what we got here. I'm going to do it this way. I'm going to go see if I can find the max, which is about 21. I'm going to say this max is about 21. And the min here is probably, well, that one's a little bit lower. Maybe this min here is about 3. All right, so my max is 21. My min is equal to 3. And then, again, remember the most important thing is the midline. So the difference between these two is 18. So that means we're going to go from the midline up 9 and from the midline down 9. So if I go up 9 from 3, I go to 12. So my midline is y equals 12. Somewhere around there. Now notice that it starts down here. It starts at a min or a max. This makes this a cosine function. So this is a cosine with a starting at a minimum. So here's what I know so far. Let me call this f of x. Wait, did they tell us what they want us to call it? Well, it's what is this, temperature? Below is the graph, number of daylight hours each day. So, I don't know, let's do hours of days. Hours of day. Here's what I know so far. I know this is going to be a negative cosine function. In fact, I know it's going to be negative 9 cosine function because I know here my amplitude. This is my amplitude. So, and I also know at the end it's going to be plus 12. Now, what don't I know? Write an equation of functions. So that's what I'm going to do here. The only thing I got to figure out now is my b value. Now, period is defined as the length of one full curve. Sine or cosine, doesn't matter. So this is, in fact, starts at a min, ends at a min. That is one full curve. Well, it looks like it finishes in about 300. Oh, well, we know it's going to finish. It's for a full year, right? It's full of full year. So I know that my number of days is equal to 365. So it starts here, ends here. So a number of days, so it finishes one full curve in 365 days. Well, period also has a formula, 2 pi over b. Well, I know my period is 365. So 365 is equal to 2 pi over b. If I cross multiply, I end up getting b equals 2 pi over 365. I now have all of the pieces. So I'm going to say let d equal days. How about we call it d, I forgot to say d equal. Let d equal day number. And h of d equal number of hours of sunlight, right? Number of hours of daylight. Let's call it daylight. So write an equation using the function. So here's my equation. H of d is equal to -9 cosine. My b value, because that's what goes in front of x, is 2 pi over 365 x plus 12. Okay, there it is. A friend looked at the graph and wondered what was the average number of daylight hours in Fairbanks over the years. What might be a reasonable answer? Well, since 12 is my midline, I think a reasonable average, if you averaged all of these numbers up and then all of these numbers up here, a reasonable average would be about 12 hours of daylight. So a reasonable answer would be 12 hours of daylight since the graph is symmetric around the line, around the line h equals 12. According to the graph, around which month of the year did the first day with 17.5 hours occur? Okay, so the first thing I'm going to do, during which day? During which month? Oh man, that's a pain in the neck question. Let's see. Let me get rid of all my stuff. 17.5. So there's my doggy. He's having fun with somebody. 17.5 would be halfway in between here, right? So if I do that, man. Okay, so this would be 150. So I'm going to guess that's around, I don't know, 120 days. So again, you can come up with a different answer so long as it makes sense. So according to the graph, where's my pen? According to the graph, the first day with 17.5 hours of sunlight would occur, it's behind my head, on or about the 120th day, which would be in, I have no idea, 31 days in January, 28 days in February, 30 days has September, April, June, and November, 31 in March. I guess if you're off by a day or so, it's not going to make a difference. So 31, 20, and 30 days has September, April. So there's 30 days in April. Let's see what I'm up to. That's 10. Carry the 1. That's 3, 6, 9, 10, 11, 12, 120. Oh, man. So let's say this is January, February, March, April. I think this is why I just looked on the answer key. I think this is why Miss Newman made this 120. I'm going to say it would be in April. I want to say in April, right at the end. All right, so we're right near the end of April. So as long as you come up with a justification there and you're approximately equal and you got a little bit of math over here maybe to defend yourself, we're good. You'll be fine. And so the model H of D disagrees. I don't know. So what I got to do is I got to plug 120 in there. So H of 120 equals -9 cosine, forgot what my equation was, 2 pi over 365. Ooh. I used X and I didn't use D. That's a problem. I should have used D here, kids. Just realize that. That would have been a -1. That would have been -1, not having an X in there. Not having an X in there instead of a D. Because it said, tell me what your variables represent. Plus 12. So I got to put this sucker into my calculator. Make sure my calculator is in radian mode, of course, which it's not. Let me do this. That's in degree mode. How about if in here? That's in degree mode. Doggone it. So I got to go into radian mode. Document settings, degree, radian mode, make default, click OK. And so we're going to go -9. Well, actually, I'm -9. Yeah, let's do it. Oops. -9 times cosine of control division 2 pi over 365 times 120 plus 12. Oh, jeez. Now it's giving me the exact answer. Oh my gosh, cancel. I think if I make one of these a decimal, it will give me the decimal answer. There it is. 16.27 days. Or hours, not days. Hours. So what we found out was H of 120 is equal to about, I forgot what we came up with. Oh, I hope it's still in here. I was just cleaning some stuff up. 16.27 hours. 16.27 hours. But that doesn't really tell us whether or not it's going to be equal to it. So maybe we should look at this thing graphically. Now, this is going to be sort of a pain in the neck, but it'll give us some practice graphing this thing. So I've already done a little bit of this. I've typed it in. There it is. It's obnoxious. It's going to look stupid. Going to look stupid. But you got to remember what your units are. I don't care about this. 0. I actually don't even care about this because I know it's got getting negative. So this is 0. So 0, tab, tab, tab. This one, the highest it's going to go is 21. So let's go maybe to 25. And this is the hard one. Remember, it's going to go 365 days. So let's go 370. And there we go. Oh, now I can see what it looks like. It looks like actually a cosine curve. So what do I want to know? I want to know when it's going to be about 17.5 days. So I'm going to press tab, and I'm going to graph the line 17.5. There it is. And I just need to find when they intersect each other. So menu, analyze the graph, intersection, click, click, 129 days. So our model, the model is slightly off from the graph since our model predicts the first day to be 129. Close enough. Really, we just wanted you to get some really good practice looking. This is a great question. All of this stuff, I believe, would give you full credit. It's a great question just to kind of look at a weird way to ask a trig question. Really weird way. All right, kids, that ends practice exam 1. I hope you stay with us. We got lots of practice exams to go. All of these exams can be found at NK Infinity. Please do me a favor. Hit subscribe, hit like. Make sure you also, when you click in there, there's a bell. There's normally a bell. Where's YouTube? Let me go to YouTube. Sign in under my other account. Leave. I'll sign in under my school account. I should be here. There it is. You know, and if you click on Kendrick Krause, there it is. And you want to subscribe. I'm already subscribed. But you click on a video. I don't know how this goes. Click on a video. Pause. Do you see how they have this bell here? That means you're going to get notified every time I go live. And I'm going to be doing some live review sessions, I believe. So take a look. Hit this bell button. I think if I hit that bell, it says send all notifications for this channel. So that means if I go live, you'll know. And I'm going to be doing some live review sessions if I can figure it out. All right, kids. Take it easy. Keep working hard. I know that was a tough one.